Hello, algebra class, pre-algebra. Today we worked on these problems, or similar ones. Okay? So go ahead and write each of these problems down. You're going to be solving these equations. So write these down, push pause, and please try them. And then I will walk you through them once you've finished them. All right, let's start with this one. This one, parentheses. If we think to our PEMDAS, please excuse my dear Aunt Sally, we need to start with the parentheses. If we look inside the parentheses, there's nothing we can do. X and 3 are not like terms. We can't do anything with those. But we can give this 4 to each piece. We are going to use the distributive property. Distributive property. Okay. You learned about this in Foundations, I think week 23, 22, somewhere around there. Okay. What that means is this 4 is going to touch the X. Okay. Bring down the plus sign. Then the 4 also must touch the 3. So 4 times the 3. Okay. It still equals the 20. Okay. That is the only part that you might not be comfortable with. That gives us 20 equals 4x plus 12. We've worked those problems before, that's nothing new. I'm going to draw this in because it might help some. All right, we're solving for x. X is our variable. That's what we want on the one side. So we're going to move everything else to the other side. This 12 is like an aunt or uncle. It's close, it's in the family, but it needs to go home. So we're going to send the 12 home. To do that, we are going to do the opposite. This is a plus 12, so we are going to subtract 12 from both sides. The 12s cancel out, and you're left with 4x equals 8. Okay. We still want to solve for x. Now we have to get rid of the 4. This is close. This is like your mom and dad and you're a teenager. You're the x. You want to send mom and dad out of the house. This says 4 times x because you're close. So you have to do the opposite of times, which is divide. But you're going to divide both sides by that 4. When you do that, x equals 8 divided by 4, which is 2. So it's not a hard problem, but you need to be able to use the distributive property, and that's very important. Okay. All right, in this next problem, it looks the same except there is an inequality sign, okay? But other than that, everything is the same. Again, I'm going to draw the dashed line just to help with the idea of crossing over, putting them on the other side. Okay. We're solving for x. Okay. You should have already worked this problem. If you haven't, please push pause and go and do it. Okay. Since we're solving for x, we need to get everything else to the other side. Send everybody home. So we're going to take the -7 and send it home. We're going to send those aunts and uncles home. This is a -7. We are going to do the opposite, which is +7 to both sides. When you do that, the 7's cancel out and you're left with 4x is less than 9 plus 7, which is 16. we are still solving for x. This says, this is like mom and dad, you want to send them out of the house. They're close to you. So we're going to have to divide them out. This is 4 times x. We're going to do the opposite, which is divide. But we have to divide both sides by the 4. The 4's cancel out, and that leaves us with x is less than 16 divided by 4, which is 4. Now, the next thing we want to do, because this is an inequality, we can actually put this on a number line. This is our x number line. Whenever we do a number line, we want to use 0. We want to use the number that we're actually looking at, and I like you to include the opposite of that number so that I know you know where it lands or where it exists. Now, what we want to ask ourselves is, does x equal 4? And no, it doesn't. Because x does not equal 4, we're going to use an open circle. We're not going to color it in because it doesn't actually exist at this point. Now, x is smaller than 4. So are we going to the left, more negative, or to the right, more positive? Well, the numbers that get smaller go to the left. We're going to color in the arrow because it continues infinitely. It does not stop. And we're going to color in the number line. This says this is the solution set for x. All the numbers less than 4 would be an answer for this. These are real numbers. If I had given you this assignment and said graph using integers, integers would be numbers such as 3, 2, 1, and you would instead put a dot, 0, -1, -2, -3, and so on and so forth. This answer solution is the real numbers, all the numbers. This type of answer solution would be the integers. Does not include the halves, the decimals, the quarters, so on and so forth. Okay? All right, now this one. This is exactly the same, except we have variables on both sides. Now, go ahead and write down this problem. Okay? And you can move, you want to get the x's together. It does not matter which way you move them. You could move the 3x to the 6x, or you might choose to move the 6x to the 3x. It's totally up to you. Both work. I'm going to show you how I would do it. I'm going to actually move the 3x to the other side. The reason I picked moving the 3x to the other side is because the opposite of +3 is -3. So to move that 3x to the other side, I have to do the opposite. I'm going to subtract 3. And you have to do it to both sides. So let's again put that little dotted line to show we're crossing over. Now, I'm not going to put the 3 and the 7 together because they're not like terms. Okay, we need to keep the x's together. Then those 3 x's cancel out. I'm left with 14 greater than 6 minus 3 is 3x. I don't have a negative. I don't really want negative numbers. If I had moved the 6 to the other side, I would have had a negative number, and I don't like negatives. So that's why I chose to move the 3 to the other side. And I still have the -7. Now, if you notice, we have exactly the same type of problem. So if you haven't solved this on your own yet, I want you to push stop or pause, and I want you to work this problem out, and I would like you to give me a number line. So go ahead on that. Okay, we are solving for x. again, we're going to get everything to the other side. I'm going to start with those aunts and uncles. So I'm going to move the -7 to the other side. To move the -7 to the other side, I have to do the opposite. The opposite of a negative or a minus is +7 to both sides. When I do that, the 7's cancel out. I'm left with 3x is less than 14 minus 7, which is 21. I want to solve for x. Now this is like mom and dad, and you're the teenager x. So I'm going to send them out, but I've got to divide us apart. This is 3 times x. I'm going to do the opposite of multiplication, which is division. When I do that, my x's cancel out. I mean my 3's cancel out, excuse me. So x is less than 7. When I put this on the number line, this is 0, this is x, this is 7, and -7. I want you to graph this using integers. Okay. If you've already done it for reals, try it again now with the integers. Does x equal 7? No, it doesn't equal. So we're going to leave an open circle at 7 because it does not equal 7. It does not exist at 7. Now, my x is smaller than 7. So I'm going to go down here to the smaller numbers, more negative numbers. Okay? Now, integers do not include a half, a quarter. They don't include any of the fractions, and they don't include any of the decimals. So that really means I have a point at 6, 5, 4, 3, 2, and I don't have room, 1. It exists at 0, -1, -2, -3, -4, so on and so forth. Because I asked that you would graph with integers and you do not have those numbers in the cracks, I can't actually color the whole line like we did over here. Instead, I would have to put little dots to show that it only exists at negative numbers, 0, and positive numbers. It does not exist at any of the numbers in the cracks, that your fractions, your decimals. Okay? If you graphed with real numbers, then you would have colored in the whole thing. And you still would have the open circle at 7. All right, so there's both options. As you move into higher math, you want to make sure that you read the directions, because this is where they're going to put these kind of things on the PERT test, on college entrance exams, SATs, and they want to know, do you know what integers are? Do you know what real numbers are? Do you know what whole numbers are? And that's where what we're working with there. Okay? All right, the next thing we touched on was a continuation of this. Here we're graphing just on a number line, but we want to learn to graph on a coordinate plane. Now, we've done this before, so this isn't new, but we're working on getting from a table to slope-intercept. So I want you to graph 4x plus y equals 8. Okay? Now, when we graph, when it's set up like this, we're going to have to solve for a variable, just like we did over here. Here there was one variable, so you just solved for it. X, solve for x. Here there are 2 variables, so somebody has to tell you what to solve for. When you're graphing, usually you want to solve for y. Okay? The reason is we want this to look like y equals mx plus b. mx plus b is slope-intercept form. Okay, and this is a main concept of algebra, Algebra 1 and Algebra 2. So we need to get to the point where we're comfortable with this. So we're going to solve this for y. So if you would like to push pause and go ahead and try it on your own, you are more than welcome to, and you should be able to. All right, so you should have solved for y. What we're going to do is we're going to move everything else, just like we did over there, to the other side. Okay, we can think of there being that dividing line to cross over. This says plus 4x. It's kind of like that understood U in English. It's the same thing. It's understood positive because it doesn't have a negative there. We're going to do the opposite of a plus 4x or a positive 4x. We are going to subtract 4x from both sides. Okay. Those 4x's cancel out and we're left with y equals. Now, I want it in this form. I notice that my x term goes first, so I'm going to put the minus 4x first. Now, the negative 4x and the 8, they are not like terms. You've got negative 4x, X-ray fish, and you have 8 people. They are not the same thing, okay? We don't do evolution, we don't do new species unless God creates them, so you can't make a new species. Your 8 must stay separate, okay? They're not like, okay? We now have this in the form y equals mx plus b. If you know how to do slope-intercept form, I'd like you to push pause and I'd like you to graph it. If you don't, we are going to set up a table. Okay? X is your input. It's the number you get to choose and put in. Y is your output. And it comes from this equation. Your answer comes from negative 4x plus 8. All right, so we are working on this problem. We are going to, if you can graph it using slope-intercept, go ahead and do that. If not, we are going to pick values for x, our input. When I input a 0 for x, that gives me negative 4 times 0 plus 8. Okay? That goes to 0. 0 plus 8 is 8. Okay? So the first point I always like to pick is 0 because it's easy to put in our table. Okay? So the ordered pair we have is 0, 8. Don't forget that's x, y. All right, the next point I'm going to pick is whatever I want. I'm going to put in a 1 for x, which gives me negative 4 times 1 plus 8. Negative 4 times 1 is negative 4. Negative 4 plus 8 is a positive 4. So my ordered pair is 1, 4. Okay? I see that my number here is going down, which I like. I'd like it to get a little bit smaller to fit in. So I'm going to pick, 3. And I just picked a number. Negative 4 times 3 is negative 12. Negative 12 plus 8, okay, is a negative 4. So that kind of jumped to the other side with a negative. I didn't expect that. All right, so 2 points make a line, and that's a geometric fact. But 3 points confirms that you have a straight line and didn't make a mistake. So what I'm going to do is going to go ahead and graph this. When my kids get to pre-algebra, algebra, I actually have them work in a composition notebook, and I usually get the one with the graph paper. That way, when they're doing graphing, you don't have to rely on them getting a straight line or picking their points, because as you can see, I tend to go a little crooked. So that is something I look for, is graph paper once they are in pre-algebra / algebra. It's a good choice to invest in. Okay. Don't forget, this is your X, this is your Y, okay? Now, you should be able to graph these points. We've worked on some graphing, so you should be able to go ahead and put these points on your graph, or you should be able to use slope-intercept to put these points on your graph. Okay, so take a minute and do that, and I'm going to put these points on my graph. Okay. This is the point 0 in the X direction and 8 in the Y direction, which was the first point I put in. My next point was 1 in the X direction and 4 in the Y direction. And my last point was 3 in the X direction and 4 in the negative Y direction. I think that might be a little over, but anyway. And then you're going to connect those points, and it should make a straight line. If it doesn't make a straight line, you've made a mistake, go back and check. Now, there are some important pieces on here. We eventually will not do a table. We want to get to the point where we'll be able to do this by using slope-intercept. So let's look at some important parts. The part right here, where it crosses the y-axis, is actually your b value, right here, which is your y-intercept. It's where it crosses the y-axis, okay? It is the point, notice, plus b. In this one, plus b. So the b value is actually 8, which fits with this. Our b value is 8, which means you have an ordered pair of 0 in the x direction, because it's not moving in the x direction. What it's doing is it's intercepting the y-axis. That is always the first point you put on your graph. Okay? It always comes after the plus sign. So if you have a minus sign, it would actually mean your b is negative. From that point, you then use your slope. M talks about your slope. Slope is whether, when we read left to right, are we going downhill or are we going uphill? In this picture, you can see we are going down a hill, and it's actually pretty steep. You might roll down this hill if you were, or a ball would definitely roll down this hill, okay? So your slope is how you are moving. In this case, we are going, our slope is going downhill, okay? Which, if it's downhill, would you be positive or would you be negative? Well, you would be negative. So this actually tells us we have a negative slope. Okay, that is this m. Anything that comes before the x is your m, okay, and that's your slope. So in this problem, it is -4. That is your slope. Your slope tells you the rise over the run. That tells you your up and down direction and your left to right direction. So what that means, in this problem, our m is -4. Okay, and you can see that right here. To make this easier, I'm going to put a 1 underneath, and that's that understood 1, okay? You don't need it, but it helps us sometimes. I know that this equals rise over run. Okay, so what I'm going to do, I'm going to go to my y-intercept, my b, and I'm going to rise -4. Well, if we're rising -4, that actually means we're going down 4. So down, 1, 2, 3, 4, okay? And we're going to run 1 in the positive direction. If we're positive, we're going to go this way, 1. And you can see it actually landed right there, which was a point we've gotten using our table. Okay. 2 points make a line, but I prefer to do 3 points just to make sure I know what's happening. This negative could also be, well, scratch that for now. This one's going to go too high if I show you that. So we're going to go down again. So we're going to rise from this point another -4. So down 1, 2, 3, 1, 2, 3, 4. And we're going to run a +1. And that puts our point right here. And again, it's on the line. The line's a little crooked, but anyway, it is on the line. Once you learn to do slope-intercept, it's so much easier than a table and a lot less chances of getting it wrong, okay? For now, you need to understand that these numbers, especially the 0 and the x, will give you your y-intercept, and then you can also use the slope, the rise over run, as you become more comfortable. Alrighty, so there's that. And that was all we did today. This actually takes quite a lot of time. So what I'd like for you to try is this one. Whether you do it with a table or whether you do it with slope-intercept. Okay, so we are going to try this problem here. Let's find one that'll work well. We had a -1 there. So let's do y equals 2x minus 7. And I want you to graph this. Now, you don't have to do any solving because it's already solved for y, okay? So all you need to do is either a table or you need to use your slope-intercept. Okay, I would like you to also tell me your slope is and your y-intercept is. Okay, and then you're going to go ahead and put it on a graph. So go ahead and push pause and go ahead. All right, so you should have either done a table and graphed it, and I would like to know your slope and your y-intercept. All right, so looking at this, I know that the form is y equals mx plus b, okay? So my m is 2. My b is supposed to be positive. So that means my b is actually -7, okay, because you have to take that sign with it. Okay, again, to get that b value, you could have put in x is 0. 2 times 0 is 0, minus 7 leaves you with the negative 7. So either way, you can see that. That is the first point you should put on your graph. So when x is 0, your y is negative 7. 1, 2, 3, 4, 5, 6, 7, which is actually down here. This is your b value. This is a positive 2 for your slope, which means it is positive, which means it's going to go uphill. So I'm expecting my line to look something like that. Okay, so if it goes the other direction, you know you've done something wrong also. You can go ahead and put numbers in, but I'm going to do this by slope intercept. Remember, I could put a 1 under there to make it easier for me. It's also rise over run. So from my b value, I'm going to rise 2, 1, 2, and I'm going to run a positive 1. That puts my point right about there, okay? If I wanted to check it, that says my x is 1. If I chose an x of 1, I would have 2 times 1, which is 2. Take away 7 would give me a negative 5, which is this point here. It is 1, negative 5. Okay? 2 points make a line, 3, you can guarantee it's a straight line. So from this point, I'm again going to rise 2 and run a positive 1, which is about right there. Okay. That's the point when x is 2, I got a negative 3. So I'm going to try it. When x is 2, 2 times 2 is 4. 4 minus 7 is a negative 3, and that agrees with what I've gotten. So I'm going to go ahead and carefully and straightly, yeah, that didn't go straight. Anyway, connect my points. This is where the graph paper would come in very handy because, as you can see, my line is a little crooked. Okay. This matches the idea we had, that it was going to go uphill. Okay. It also matches the points that I plugged in. Okay. We want to eventually be able to do this just by slope intercept, but here's the table if you need it or if you want to check your work and you're not quite sure yet. So for homework, you have a worksheet, and you should try all these problems that we've done today, or I've done on the video, and we will continue these next week. All right, we'll see you then. Thanks for joining me. Bye.